I hope everybody's good this morning. Thanks for coming in. Here's my really quick agenda. I won't keep you for the whole time. I will open it up at the end for questions if you want to talk a little bit about scheduling. I think you guys are going to start scheduling next week, so we can also do that if we want. But I just wanted to take some time and see if anybody had any questions. And also to remind you of the two topics. I feel like this week has been kind of disjointed, so I wanted to make sure that everybody knows that the two things that are on the quiz this week are polyatomic naming and binary naming, and then the formula, weight, and percent composition, which is what we did yesterday. So you want to make sure that you've done the lecture questions and the lecture for both of those. So hopefully you're feeling good with that stuff. And then I do have the participation points in for the Thursday folder, but I thought I did them right because I took Tuesday out, but then I didn't put a Thursday in. You know, I just go in and do the participation points. And I always check them anyways to make sure that students that were here get their points. So we'll make sure we get those correct. The only other thing that I want to start off by talking about is the quiz. It's fairly straightforward. It is going to be 15 questions and 30 points. It means each question is worth 2. It's open from 7:30 until 1:30, and it has all types of naming. And then there's 2 formula weight questions and 2% composition questions. So we're going to go over both of those things today, or all 3, I guess I should say. And so hopefully you're going to be feeling good and prepared for your quiz tomorrow. I want to start with what I think might be a little bit easier, kind of depending on your math level, I guess. But I think that formula, weight, and percent composition are pretty easy. So let's start with that, and then we'll go back to the naming because sometimes that's a little bit harder for students. So there's 2 mistakes that are usually made when you're doing formula, weight, and percent comp. So you want to find this worksheet in your packet. And the number 1 mistake that's easy to make is students don't pull the elements out all by themselves. I saw yesterday some students trying to say, all right, so I'm going to do NH, and I want to know the mass for NH, but that's not, you have to pull out each individual atom. So element N, H, S, and O for this ammonium sulfate here. If you were going to do this next one, C, H, F, and BR. Okay, so you just need to make sure that you pull it apart when you are by every single element. Okay, the only other thing where people usually make a mistake is doing your subscripts. Make sure you know that if it's outside of a parentheses, it distributes through the whole thing, and that means multiplication. So how many phosphorus do I have here? I have 2 phosphorus, but how many oxygen do I have? It's 4, 2 sets of that. So the total multiplied is 8. So just be very careful with that kind of thing. Okay, so let's do one together, shall we? I don't think you need to do the water because we did water yesterday, but let's do this aluminum oxide. So on your quiz tomorrow, you will absolutely need a periodic table and a polyatomic ion sheet and something to calculate with. So you can see aluminum oxide. What 2 elements do I have in aluminum oxide? I have aluminum and I have oxygen. Hopefully everybody can see that. And then let's talk about how many I have. It's Al2, so I have 2 aluminums, and then O3, so I have 3 oxygens. As soon as you have that written down, then you need your periodic table. And remember that we are going to always round off the periodic table. And when we're rounding, aluminum is 26.98. So I'm going to call that 27. And oxygen is 15.999. So I'm going to call that 16. So we can say that aluminum is 27 and oxygen is 16. Does anybody have any questions on how we got this far? All right. Good. Now we're just going to do our arithmetic. 2 times 27 is 54. And 3 times 16 is 48. So those are the individual element masses. And then for the formula weight, so you can see on the quiz tomorrow, you're going to have 2 that just do formula weight and then 2 do the percent composition. This one just wants to know the weight of the formula. So all you have to do is add these 2 bad boys together. Boom. The formula weight for aluminum oxide is 102. Okay. So hopefully, I don't want to do too many of these for you because this is your practice, but you pull again, you pull out each element, tell me how many you have, multiply it by the form or by the weight of one of them, and then you add it all up in the end. Okay. And I have the key for this. So what I'm going to leave some of these for you to do. What I want to do next is one of the percent composition ones. It's not that much harder. Just one more step. I think you guys will be great. So down here at the bottom, it says calculate the percent composition of each. So that's when I'm going to know what percentage by mass is each of the individual elements. So you're going to do the same thing. Calcium fluoride has calcium and fluorine in it. It has 1 calcium and 2 fluorines. If we look at calcium, again, we are always going to be rounding. Calcium over here is 40.0. So I'm going to call calcium 40. And fluorine is 18.998. So we're going to call that 19. All right. So calcium is 40. Fluorine is 19. So let's do our math. 1 calcium is 40. And 2 fluorines is going to be 38. Now, the first thing you have to do when you're doing percent composition is you do need to get your formula weight. So I'm going to add that up. And my formula weight is 78. Now, if you were taking a test and I told you that you got a 40 out of 78, how would you know your score? Well, what you would do is you would do 40 divided by 78. So the part divided by the whole. And then you would get a really small number. And you either would multiply that by 100, or you can just move the decimal twice. Most students just do that. But at the end of the day, if you have your calculator here, 40 divided by 78 equals, move the decimal because you probably got 0.513. That's 51.3%. Good. And then you're going to do the next part divided by the whole. So I'm going to do 38 divided by 78 and then 48.7%. Don't really worry about rounding because you guys will, it's multiple choice. So you'll just pick the one that I rounded correctly there for your final answer. Okay, so the only step that's different on percent composition is that you just have to then take each individual element and divide it by the total and multiply it by 100 to get a percentage. Okay, so that's the first skill. You're going to have sets of those on the quiz tomorrow. Does anybody have any questions that, did I go too fast on that? How are we feeling with that? Good, awesome, perfect. All right, so then the only other thing that we have, and I think it's the next page in your packet. I could be wrong. Wonderful. After that, let me make sure it's right. Oh, I think it's the page before that now that I take a look at it. You do have another formula weight percent composition worksheet if you would like to do that. But if you would go, I guess, backwards kind of before that, the harder of the two things I think is the naming. So if you could find the reading and writing chemical formulas practice number 3. You do need your periodic table and your polyatomic ion sheet for this one. No calculator needed for that. Kind of what I tried to do with this worksheet is I try to write some common mistakes that I see so that we can kind of break it down and then see if you were to make any of these mistakes, if we can pull you out of that pitfall. So the first thing, whenever you're writing a formula, you take a look at the charges. So I have potassium and I have nitrate. So I look over here at potassium. I go up. Potassium is a +1. So potassium, +1. Nitrate, if you look on your polyatomic ion sheet, is NO3 and it's a -1. Okay, so here are some, there's only one right one up here, and let's try to figure out which one's correct. So potassium and nitrate, though, is a big N, a big O, and a 3. So this one is wrong because it's not N and then a little o. The next one here, let's take a look at. Is this right or wrong? Well, let's draw it out. If I had +1, +1, and -1, does that equal 0? That's not neutral. So that one's wrong. The next one is also incorrect because I don't need these parentheses. Okay, you never put anything off the periodic table in parentheses. You never need parentheses if it's just one thing. Okay. The next one is also wrong because there's no need for parentheses around the nitrate if I don't need more than one. Do you see it's just cluttered? The correct answer here is just KNO3. There's no need to put any parentheses in. It just is wasteful, making clutter. So that's also wrong. Okay. Perfect. All right, let's try another one. So beryllium, if you look up beryllium on your periodic table, it is Be. Be is a +2. And then acetate, if you look on your polyatomic ion sheet, it is the first one at the top, and it is a -1. So let's think in our head. If this is +2 and this is -1, how many you would need of each? And let's try to see if you can't figure out which one is the correct one. All right, again, the last one is the correct one. Let's figure out why the other ones are wrong. So Be is a +1, excuse me, not boron, or +2. And then your acetate is C2H3 and then O2. Okay. And how many of these do I need in order to be neutral? I need 2 of them. So I need 1 beryllium and 2 acetates. There's no reason why you should put all the parts of the polyatomic ion in their own little parentheses. Here, this is not neutral. I need a 2 here in order to get that one to be correct. So that's not right. And then I don't know what's going on here. Some silly mistakes. This would need to be a closed here, and then you don't need this one parenthesis here. I have no idea. But so the right one here is the BeC2H3O2 in parentheses with a 2. Okay, awesome. Now, it says write the chemical formula for sulfide, sulfate, and sulfite. So it's going to be really hard tomorrow because you're going to have you'll have the binary and the polyatomic mixed together. So you want to make sure you know if it is an IDE ending. And I suggest on your periodic table that you've written the letters IDE at the top. And remember that that's any of these non-metals here. Oh, I guess not the noble gases, but any of these non-metals here have an IDE ending. Okay, so when you see the word sulfide, that means we're talking about sulfur with a -2 charge. Sulfur, -2. Sulfate is off your polyatomic ion sheet, and that's SO4, -2. And sulfite is also off your polyatomic ion sheet. That's SO4, SO3, -2. Okay, so the biggest thing is to make sure that you have your charges on your periodic table, and you know that if it's an IDE ending, with the exception of like hydroxide, that is a polyatomic ion. But if you see an element with an IDE ending, we're off the periodic table. Okay, awesome. Good stuff. So then what your quiz will look like is more like this. I will have on your quiz, please name this following compound. And so you see when your naming is actually quite simple. You just write the name of the first name, which is lithium. And then you write NO3 because it's a polyatomic. I'm going to look on here, and that's lithium nitrate. Okay. Awesome. Then again, we have sodium, which is Na. And then HCO3, you're going to have to look on here, HCO3. Bicarbonate, and I'm probably going a little fast. I'm realizing that. I'm just talking to myself, so I go faster. I just want to get to the third example here. You always write the first name, magnesium. Then you have bromine. And remember, if you have bromine here, bromine's right here, he needs an IDE ending. So it's not bromine, it is bromide. Okay, so I don't want to take them all from you. Make sure that you guys know how to do this. But again, if it's off the periodic table like here, this is an IDE ending, oxide. Okay, so flip it over. There's a couple of those that you can do with the naming. I think the harder thing to do is actually to do the formulas. So I want to do a few of those with you as well to get you guys ready to take some time and to study before your quiz tomorrow. So whenever you're writing a formula, you need to make sure that it is neutral. You can't just go along and willy-nilly say, all right, magnesium nitrate. All right, that's Mg for magnesium, and nitrate is an NO3. That is not neutral, and that is incorrect. And I will put that on your quiz tomorrow, and if you don't know what you're doing, that will be wrong. Okay, it has to be neutral. So what do I mean when I say it has to be neutral? You need your periodic table. We're going to look for magnesium. Magnesium's right over here. He is a +2. +2. And nitrate, I'm going to get off of my polyatomic ion sheet, and he is a -1. Okay, so if I have +2 - 1, does that equal 0? It does not. So I need 2 nitrates. So what you're going to think in your head is this nitrate, this thing, NO3, I need 2 of them. So they have to be in parentheses. Oh, that's a very big eraser. Erasing too much stuff. Okay, so the correct answer for magnesium nitrate is MgNO3, 2 of them to make it neutral. Okay, now I'm going to jump on over. It's probably not the right way, but I'm going to jump on over to this one. Boron sulfide, because I want to do one with an IDE ending. So again, I'm going to look up boron on my periodic table. He's right over here, number 5. Boron is a +3. So I'm going to write that above boron. And then sulfide, IDE ending. If you have an IDE ending, you are also looking at the periodic table. Boop. And sulfur, sulfide, you can barely tell because of all my writing, is a -2 charge. And hopefully you have that written down on your periodic table. So when I see this, if you were to just write B and S, that's wrong. 3 and 2, it happens a lot, so you probably know what we're doing here. You want to get them both into 6. So how many borons do I need to be +6? I need 2. And how many sulfurs do I need to be -6? I need 3. Okay, so the proper answer for boron sulfide's formula is B2S3. All right, hopefully we're doing okay. I want to do a couple more for you, and then we're going to let you go practice. Thanks for coming. Let's do ammonium sulfate. Let's see, I might pause a second. Can you do ammonium sulfate? Don't forget, everybody forgets where ammonium is. Ammonium is right over here. See how I even highlighted mine? Because sometimes you forget. Check out the charge of ammonium. Check out the charge of sulfate. How can you write it neutrally? All right. Ammonium is a +1. Sulfate is off the polyatomic ion sheet. That's a -2. Okay. And so what we're going to do here is you would usually have ammonium, which is NH4, and sulfate is an SO4. Okay, how many do I need of each in order to make this neutral? Well, I need 2 ammoniums for every 1 sulfate in order to make it neutral. So you can't just write like a 2 here. You got to put it in parentheses. I want 2 of that whole thing. Okay, so it'll be NH4 in parentheses 2 SO4. Okay, awesome. Last one I'm going to do, then we're going to see how you're doing. Potassium +1 off the periodic table. I guess I should show you here. Oxide. So this has oxide. IDE ending also tells me I need to be off the periodic table. Oxygen over here is a -2. Perfect. So how would I make this neutral? K2. Oh, 2 potassiums, 1 oxygen, neutral, boom. Okay, so I think I've done enough examples, hopefully, for you to kind of get going. What I want to point out to you is in the week 22 folder, in the Thursday folder, which is where we're at, you have your participation points that you want to do, and then I have the answer keys to both of these worksheets. So what I would really like for you guys to do here while I'm calling roll and afterwards, because we still have like 20 minutes left in class, I would like for you to do a few of these, and I would like for you to check the key and make sure that you know what you're doing. And if you have any questions, please don't hesitate to let me know. Even if it's after class, email me and we can definitely touch base, because you got to know how to do this stuff in order to be successful in stoichiometry, which is the next unit. So super exciting. So what I'm going to do, the only other thing that we really didn't get a chance to talk about a lot, and I feel bad if I leave before we get a chance to talk about it, is scheduling for next year. So if you do have any questions on scheduling, you can kind of just shout them out when I check in with you today, or we can talk about it next week. You can talk to Mr. DeChant about it. Obviously, he knows all the courses and stuff like that. But I was just going to leave this up here while we check everybody out. And if you do have questions, don't hesitate to ask, but everybody should sign up for science next year. You need at least 3 sciences to graduate. You need a physical science, which if you took physical science, that's a physical science, or this is also a physical science. You need a biological science, which you hopefully have taken biology, and then you also need an advanced science. So any class you take after this will be considered an advanced science. So as long as you take this and biology, you have your first 2 requirements under control. And then this can also be an advanced science if you took the physical science, or you can take anything else above this. Okay. So number one thing though to remember is tomorrow you do have your quiz. The quiz is open from 7:30 until 1:30. It's 15 questions and it's over all the stuff we just did today. So hopefully if you understand that, then you will be good to go.